In this episode, we're going to look at how to do variable length subnet masking design and implementation. I'll show you how to do it, and we'll have a good discussion about these topics as I show you how to do this. In this activity, we're going to be given a /24 network to use to design our Vlsm addressing scheme. Based on a set of requirements, we're then assigned subnets and addressing, configure devices, and then verify our connectivity. We'll be discussing the network requirements, designing the Vlsm addressing scheme, and finally assigning IP addresses to devices and verifying connectivity. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Vlsm design and implementation practice. I have the lab open. On the left side, I have our working area where we have all of our devices. This is where we're going to do the configuration. On the bottom right is the standard packet tracer activity window. Gives us our instructions. The upper right, I have the Word document of the instructions. What this allows me to do is go through and answer the questions, fill in the charts. A word of warning, not necessarily warning, but a word about how this packet tracer lab works. When you open it up, you will get a different scenario every time. The layout over here of the network is going to be different. The devices are going to be different, and the network address you are actually going to use. There's 3 layouts, there's 3 device name options, and there's 3 network addresses. 3 times 3 times 3, you have 27 different possible combinations that you may get, permutations of this exercise. So you could do this 27 times and not have a single time be the same. This walkthrough is for this exact exercise over here. It has building 1, building 2 in the center, these 2 routers there. It has the layout is sort of an sideways H, which you see right there. And then our network address is 10.11.48.0/24. If you don't have this, what you can do is close and reopen this, or you can come down here and click on the reset activity button. Click on the reset activity button. They're going to say, are you sure? You can go ahead and click yes. It will load up a new randomly generated layout. Keep hitting reset until you get that. Once again, I said there's 27 possible ones. This may take a lot of resets. This may take you a little bit to get here, but you will get there eventually. If you're going to follow along, I suggest you go through that process of loading that in multiple times until you get the exact match here. Building 1, building 2 in the center. The layout looks like a sideways H, and then you have the network of 10.11.48.0. Let's get started. Over here in our Word document, I got a little statement here stating what I just told you. I have what the layout should look like. We have our addressing table. Once again, we're going to be going through designing an addressing scheme. We're going to be going through, once we're done, we're going to fill out this entire chart. Once we have it filled out, we'll come over here and configure some devices. Our objectives here: examine the network requirements, design Vlsm addressing, assign IP addressing. They're going to give us a /24 network. And then we have to figure out how are we going to do that. Now, Vlsm, variable length subnet masking, is different than normal subnetting where all the subnet masks stay the same, regardless of the requirements. Here, we look at our network requirements, how many hosts per network, then we match our subnet mask according to that. Each network is going to have a different subnet mask. It's variable between networks. One may have a /26, one may have a /28, another one may have a /30. All part of our process. The key with Vlsm is to remember, always work with the biggest requirements first. Always work with the network that has the most hosts required first. Once you do that, then you can go on to the next largest one, or the next smaller one, and so on and so forth till you process all the way through it. But always start with the biggest network requirement first. In our document, examine part 1, examine the network requirements. Determine the number of subnets needed. As we look over here, here's our network address. We have AS1 LAN, AS1 LAN. AS1 is our switch here. This is a local area network here. That includes host A, AS1, and this interface on the building 1 router. Doesn't include the whole router, it's just that interface. That is our LAN 1. There we need 14 hosts. AS2 is our bottom left over here. That includes host B, ASW2, and this interface on building 1. If we mouse over here, it will tell us that it is gig 01. ASW3 requires 6 hosts. ASW3 is right here. Once again, it includes this interface on the building 2 router. ASW4 needs 60 hosts. Whoops. That is this network over here, including this interface. That gives us 1 network, 2 networks, 3 networks, 4 networks, and then there's 1 more network. That is the network that goes between building 1 router and building 2 router. This wide area network, once again, we know it's a wide area network because it's represented by this red lightning bolt between there. That's a wide area network. That has to be a separate, different network than the other 4. We need a total of 5 networks here. We have a total of 5 networks. We have 4 LANs, 1 WAN. Determine the subnet mask information for each subnet. Looking at the questions, which subnet mask will accommodate the number of IP addresses required for AS1 LAN? Down here, this is AS1 LAN. It's named after the switch that's there. It needs 14 hosts. So what subnet mask will work for that? What /number? Okay. I think our approach should be to figure out how many hosts per subnet when we borrow bits. Once we figure that out, we can then figure out how many bits we're going to borrow. That then can give us our custom subnet mask, our new subnet mask. What we're going to do is up here, I'm going to build a little chart. The formula to figure out how many hosts per subnet, once again, is 2 to the number of host bits that we have. That's the host bits, that's the N, that's the zeros on the subnet mask. And then we can't use the first one, we can't use the last one, so we subtract 2. And that gives us number of hosts per subnet. And what I'm going to do is start with 1. I'm going to go through, start with 1 here. Just give me some formatting right here. 2 to the first power minus 2. That will give us any number to the first power is itself. 2 minus 2. That will give us 0 hosts per subnet. And once again, I'm going to go here. And the subnet mask that we have is we have a /24. That's what was given from us, from our ISP, from your network administrator. And so we'll start off with writing our subnet mask in binary. We'll start off with the /24. That gives us 3 sets of 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot, and then the host portion is all zeros. fill it in until you get up to 32 bits. We need 8 zeros. That's 4, 5, 6, 7, and 8. That is what our default subnet mask is. That is our /24. So our /24 is equal to that. If we have 1 bit in the host portion, and so that means we have 31 bits in the network portion, that gives us a /31. That gives us 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot. I have one too many ones right here, right? 1, 2, 3, 4. Oh, I'm short one up above. There we go. And then, like I said, 31 bits in our network portion. So we have 24, 25, 26, 27, 28, 29, 30, 31, 32. That is our /31. That gives us 0 hosts per subnet. Gives us 2 IP addresses, but you can't use the first one. That's network address. Can't use the last one. That gives us the broadcast address. So there's no usable host in there. Now, what I'm going to do is, instead of having 1 bit in the host portion, I'm going to have 2 bits in the host portion. 2 to how many bits are in the host portion? And that was 2 minus 2. Can't use the first one, can't use the last one. That gives us 2 times 2 minus 2 there, which is 4 minus 2. That equals 2, and that's hosts per subnet. That gives us 2 hosts in the host portion, /30 now, because we have 2 in the host portion. All the rest is network portion. Our IP address is 32 bits long, right? And if we have 2 in the host portion, that means we have 30 in the network portion. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4. Actually, we'll start off. This is 24, 25, 26, 27, 28, 29, 30, and fill in the last 2 bits there. That will give us 2 hosts per subnet. What we're looking for is AS1 14. 2 is way short of 14. Let's go and borrow. Let's go and have 3 bits in the host portion. 2 to the third. Once again, 3 represents how many bits in the host portion. Can't use the first one, can't use the last one. That is equal to 2 times 2 times 2 minus 2 gives us 2 times 2 is 4 times 2 is 8. 8 minus 2 gives us 6 hosts per subnet. If we have 3 bits in the network, or sorry, 3 bits in the host portion, our IP address is 32 bits long. 32 minus 3, that's 29. 29 bits in the network portion. I'm going to continue this little chart up here. /29. So we have 29 ones. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8, which is 16. 1, 2, 3, 4, 5, 6, 7, 8, which is 24. 25, 26, 27, 28, 29. 1, 2, 3, 4, 5. Remember, this octet is 8 bits long, so we need to fill it in with zeros, which has 3 zeros. That was equal to 6 hosts per subnet. Six hosts per subnet. AS1 has 14 hosts. That is still way short. Let's go and have 4 bits in our host portion. 2 to the 4th. We'll hit tab over. Can't use the first one, can't use the last one, so we subtract 2. That gives us 2 times 2 times 2 times 2 minus 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 minus 2 gives us 14 hosts per subnet. If we have 4 bits in our host portion, our IP address is 32 bits long. 32 minus 4 gives us 28 bits in our network portion. Gives us a /28, which is equivalent to 28 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. This is 8 bits long, so we have to fill in the remainder with zeros in the host portion. 1, 2, 3, 4. Once again, that's what we have here is 4 bits in the host portion. And that gave us 14 hosts per subnet. 14 hosts per subnet. Down to question A here. Which subnet mask will accommodate the number of IP addresses required? Once again, we have 14 hosts that are required. If we have 4 bits in our host portion, that gives us a /28. That gives us there. Our subnet mask is a /28. /28 there for our subnet mask. How many usable host address will this subnet support? We calculated that out here. 2 to the 4th power minus 2 gave us 14 hosts per subnet. 14 hosts. On to B. Which subnet mask will accommodate the number of IP addresses required for ASW2 LAN? Here's ASW2 LAN. That needs 30 hosts. Well, we are at 14 hosts, which is way short, so let's continue this chart out. Now, instead of having 4 bits in the host portion, we're going to increase that to 5 bits. 2 to the 5th. We subtract 2 because we can't use the first one, can't use the last one. That gives us 2 times 2 times 2 times 2 times 2. 5 times in there. Minus our 2 IP addresses. That gives us 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 minus 2 for 30 hosts per subnet. And if we look at our chart, that's what our requirement is, 30 hosts per subnet. We have 5 in the host portion. I'm going to go up here, fill in this chart right here. If we have 5 in the host portion, our IP address is 32 bits long. 32 bits minus 5 is a /27. I'm going to go ahead and fill in a /27 here. /27 is equal to 27 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That's our /27. And then we should have 5 bits in the host portion. That's what we calculated out here. And if we look, 1, 2, 3, 4, 5, that gives us a total of 8 bits in the octet. That works out. And that gave us, once again, 30 hosts per subnet. 30 hosts per subnet. That was our requirement over here for the AS2 LAN. I'm going to scroll down here. Which subnet mask will accommodate the number of IP addresses? 30. That was our /27 network. /27 will give us 30 hosts per subnet. That's how many usable host addresses there are. So there are 30 hosts at that. Question C. Which subnet mask will accommodate the number of IP addresses for ASW3 LAN? ASW3 LAN is over here. We have ASW3. Their requirement is 6 hosts. We can go up here, look at our chart right here. and we notice right here is 6 hosts. 6 hosts is a /29. Well, we figured that out already. And so our subnet mask here is a /29. How many usable host address? Once again, if we look up here for our /29, there are 6 hosts per subnet. 6 hosts. D, which subnet mask will accommodate the number of IP addresses required for ASW4 LAN? ASW4 is the upper right LAN right here, has the ASW4 switch in it, and they need 60 switches, 60 hosts, 60 hosts. We are up to 30 hosts. Well, we need to take it another step further. Instead of having 5 bits in the host portion, we're going to go up to 6 bits in the host portion. 2 to the 6, that was for our 6 bits in the host portion, minus 2, because we can't use the first IP address, can't use the last one. That gives us 2 times 2 times 2 times 2 times 2 times 2, minus our 2 addresses we can't use. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 64 minus 2 gives us our 62 hosts per subnet. Now, our requirement is only 60 hosts, but the numbers work out where we're going to have a couple extra. And having a couple extra is fine. As long as you're not short, having a couple extra is fine. And so having 6 bits in the host portion, that's going to work out good. I'm going to go back up here because we have 5 bits in the host portion. I'm going to do one more line, figure that out. That is a /26. 26 bits in the network portion. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. That gives us our 26 ones in the network portion. We need to fill out the remainder of these 8 bits here with zeros. 1, 2, 3, 4, 5, 6. If we look down here, our calculation said 6 bits in the host portion. That makes sense. It all fits in there. And that was equal to 62 hosts per subnet. The /26 gives us 62 hosts per subnet. /26. And that gives us 62 hosts per subnet. Question E, which subnet mask will accommodate the number of IP addresses required for the connection between building 1 and building 2? This is that connection over here from building 1 to building 2. It's a WAN connection. It's a high-speed serial connection between that. This high-speed serial connection is a point-to-point network. You can add no other devices in here. You only need one IP address here, down on building 1, and you need a second IP address there. You need a total of 2 IP addresses. Let's look up here, look at our information. Looking here, we have 2 hosts per subnet. A /30 will give us 2 hosts per subnet. That sounds perfect. And actually, in industry, that's what a lot of people use on their serial point-to-point connections is a /30. It only gives them 2 IP addresses because that's all you can use on that point-to-point network. Question, which subnet mask will accommodate that? Once again, that is a /30 subnet mask. Now we went through, we calculated out our requirements, the subnet mask, how many usable addresses we have. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com, for all of my details and how to get these episodes in video and podcast form. Part 2, design the variable length subnet masking addressing scheme. Divide this network, the 10.11.48.0 network, based on the number of hosts per subnet. Now remember, the key here is when you're doing VLSM, start with the largest requirement first. Use the first subnet to accommodate the largest LAN. Then we go to the second LAN, then the third largest LAN, then the fourth largest LAN, and then the last one here is our point-to-point connection. And so we will do that. Step 2, document our VLSM subnets. Okay, we're going to assign them, but then we're also going to document them. So I'm going to combine steps 1 and steps 2 together. First thing in our table is a description of our subnet. We want the biggest requirement first. If we look over here in our diagram, we see that we have 14 hosts on ASW1, we have 30 hosts on ASW2, we have 6 hosts on ASW3, and 60 hosts on ASW4. 60 hosts is by far our biggest requirement. And so I'm going to give us a description here of ASW1 LAN. That's the local area network that this switch is in. That's how we're identifying it. We need 60 hosts. There. Now, what is the network address and the slash number? Here they have a slash CIDR, CIDR, classless interdomain routing. And what that means here is we are not doing addressing and subnetting based on the octets. We are not doing it on /8, /16, or /24. We are doing it on something else there. We're doing it on a /25, /26, /27. And so we have to specify that. Now, when we first start out here, the first network is going to have this address. 10.11.48.0. That's our starting, that's our network address. Once again, we can't assign that one. The first usable is one bigger than that, 10.11.48.1 is our first usable address. Then I'm going to skip the last usable host address for a second and look at our broadcast address. Our broadcast address is when we use this address here and we have the host portion. And so what we're looking at here is the /60, or sorry, 60 hosts per network. 60 hosts per network was a /26. That means there's 26 bits in the network portion. And then what's left of the 32 bits of our IP address, that's the host portion. So we have 6 bits in the host portion. We have 62 hosts per subnet. We have the /26. That is our subnet mask for our requirement of 60 hosts. We have 62 hosts per subnet. Now, remember, we can't use the first IP address, that's the network address. We can't use the last IP address, that's the broadcast address. So we have the host address, or sorry, the network address, then we have 62 host address, and then we have the last address, which is the broadcast address. Can't use the first one, can't use the last one, but we have 62 usable, 2 unusable. We have a total of 64 addresses in this network. And if we look here, this is our starting address. This is our network address. If we add 64 onto that, we get our broadcast address. Remember, we're starting with 0. So our first address is 0. Add on 64. That takes us up to 10.11.48.63. That's 64 addresses total in here. Now, once we have our broadcast address, we can use the last usable host address is one less than this. We have 10.11.48.62. That gives us all of our information for this. Now, that took care of A right here, the first subnet for the largest one. Then we use the second subnet, the second largest network. If we look back here, our first one was 60. The second down here is 30 hosts. And I'm going to go enter in that information. We're looking at our ASW2 network. Oh, this should have been ASW4 right here. My fault. So the largest one here was ASW4. I got that correction. Second largest here was the 30 hosts on ASW2. ASW2 LAN is a good description. Our required number of hosts here is 30. Now, to get our network address is the next address after the broadcast. If you've noticed, the broadcast address of one network, add 1 to that gives us the network address of the next network. And so we have 10.11.48.63 here. Add 1 to that, that'll give us .64. 10.11.48.64. What I forgot to do in this line up here was add in our slash notation for our subnet mask. We had 60 hosts up here. We decided it was a /26 when we went through and we filled in this information up here. All we have to do is come down here, add in a /26 at the end. For ASW2 LAN, we came up with, and right here is ASW2 LAN, we came up with a /27. And all we have to do is add in a /27 at the end. We have our network address. Ends in a .64 to get our first usable. All we have to do is add 1 to that. That gives us 10.11.48.65. I'm going to scroll back up. Look here at our ASW2, a /27 has 30 hosts, usable IP addresses. There's the addition of the network address you can't use, so that's another one that gives us 31 IP addresses there. Can't use the last address, the broadcast address. That gives us 32 IP addresses. And what you can do is you can add 32 onto this, 64 plus 32 addresses, and remember 64 is the first one, 65 is the second one, and if you follow that all the way up, that gives us a last octet here of .95, 10.11.48.95. Once we have our broadcast address, we can figure out the last usable host. We subtract 1 from the broadcast address, that gives us 10.11.48.94. That takes care of step 1B. We're going to use the third subnet to accommodate the third largest network. We did 60 was the largest, then 30 is the second largest. Third largest is 14 hosts. That is our AS1 network. ASW1 LAN will be our description of it. We need 14 hosts on there. To figure out what our network address is, you look at the broadcast address from the previous network, add 1 to it. So we have a .95 here, add 1 to that. That gives us a .96, 10.11.48.96. And then we have to put our slash CIDR notation, our slash number on it, our slash subnet mask. Go up to ASW1 here. For ASW1, right here, we decided it was a /28. We can come down here and we put a /28 in there. Oh, we got to put the slash in there. This is our network address. To get our first usable, we add 1 to that. That gives us 10.11.48.97. For ASW1, we have 14 usable addresses. We have 14 hosts, plus we have the network address That's another one that gives us 15 IP addresses. And the broadcast address, the last one, you can't use it, but it is an IP address that gives us 16 IP addresses on our network. If we add 16 here to 96, remember 96 is the first one, 97 is the second one. We add in 16 here. That will give us a broadcast address of 10.11.48.11 at that point in time. Once we have our broadcast address, we can figure out what the last usable is. Subtract 1 from the broadcast. That gives us 10.11.48.110. We have our third network information. Network address, our subnet mask, first usable, last usable, and broadcast. That takes care of step 1C. On to step 1D. Fourth subnet to accommodate the fourth largest network. 60 was the first one, 30 was the second one, 14 was the third one. And once again, we're going from biggest to smallest. And the fourth one here is 6 hosts. ASW3. I'm going to go ahead and put our description in there. ASW3 LAN. It was required that we have 6 hosts there. To get our network address, I add 1 to the broadcast address from right here. That will give us 10.11.48.112. If we scroll back up to our ASW3 LAN, we decided it was a /29. Let's put that /29 in here for our CIDR notation. First usable, you add 1 to our network address. Gives us 10.11.48.113. For our ASW3 LAN, I'm going to scroll back up. ASW3 LAN has 6 hosts, 6 usable IP addresses. The first IP address is the network address, not usable, but it is an IP address. So we have 7 IP addresses, and you can't use the last IP address. That's the broadcast address. That gives us 8 IP addresses. If we add 8 onto 112, it's not 120. Got to remember, first one here, first IP address is 112. Add 8 onto that. That brings us to 10.11.48.119. That gives us 8 IP addresses, .112 to .119. Once we have our broadcast address, we can figure out our last usable. All we do is subtract 1. Gives us 10.11.48.118. That takes care of step 1D here. On to step 1E. Use the 5th subnet to accommodate the connection between building 1 and building 2. Remember, this is a special connection. This is a point-to-point connection. We only need 2 IP addresses. Come up here where we established that it's a /30 address. We only need 2 usable IP addresses, but we still have the first usable address. Or sorry, we still have the first unusable address. That's the network address. We still have the broadcast address. That's the last address. We still have a total of 4 IP addresses in that network. Can't use the first one, can't use the last one. That gives us 2 usable in the center. When you fill out these charts and you're dealing with a /30 network, I'll show you a little trick here. Let's give a network subnet description in here. This is our WAN link. Right there, we need 2 usable IP addresses. To get our network address, we just add 1 to the previous broadcast address. That gives us 10.11.48.120. Our / notation that we figured out up here was a /30. Add in our CIDR notation right here, /30. Because we only have the network address, first usable, last usable, and broadcast address, these all go in numerical order. So our network address was 120. Our first usable, add 1 to that, which is 10.11.48. Add 1 to this right here. gives us 121. Our last usable, because we only have 2 IP addresses, you just add 1 to that first usable, gives us 10.11.48.122. And then our subnet mask, or sorry, our broadcast address, we add 4 onto that. 120 is the first one, 121 is the second address, 122 is the third one. The fourth IP address is 123, or if you notice, it's just continuing in the numerical sequence. So our broadcast address here is 10.11.48.123. That fills in our Vlsm subnet table. Once again, the key is start with the largest requirement first and work your way through that. Step 3, document the addressing scheme. What we're going to do here is fill in the addressing table at the top. These are our requirements. Step 3A, assign the first usable IP addresses to building A for the 2 LAN links and the 2 WAN links. Over here, building 1 is down here. We have 2 LAN links. This is LAN 1, this is LAN 2 here. And so these 2 interfaces are our LAN links. We're going to assign the first IP address from these networks to this interface here. And once again, if I mouse over here, it's going to say this is gig 00 here. And if I mouse over here, it's going to show me that gig 00 is this port right here for our ASW1 LAN. If I mouse over here, it's going to show us that our port right here is gig 01 for our ASW2 LAN. Then we also have our WAN link. That's this network right here. So let's go ahead and start filling this out. Up here, we are dealing with building 1, G00. That is this ASW1 network. If we scroll down here, we have to come to this table we just filled out. ASW1 network. Coming over here, our first usable address is 10.11.48.97. We can go ahead and take that number, put that in here, 10.11.48.97. Then we have to put the subnet mask. A slash number will not work at this point in time. What you have to do is convert that into a decimal number. I'm going to scroll down here. I'm going to come to this chart where we filled this out back here in part 1, step 2. And what we can do is we can take this number and we can convert this into decimal. The first 3 octets are easy. If we have 8 ones, that's 255, 255, 255. And then we go through and we take the values here. I'm going to start with the bottom one here. And you'll see why in a second. And so we have the first octet. I'm going to put that in. I'm going to start it off down here. I'm going to put it in here. 255, first octet. Second octet's all ones. 255 again. Third octet here is all ones. I'm going to go ahead and put that in there. And then this one, we borrowed 2 bits here for the networking portion. And then we have all ones here. And remember, we have the values here. This is the value of this column is the 1s, this is the 2s, 4s, 8, 16s, 32s, 64s, 128. We have a 1 in the 128 column, we have a 1 in the 64 column. Add 128 to 64, that gives us 192. That is our subnet mask for a /26. A /26 is equivalent to 26 ones followed by 6 zeros, which is equivalent to 255, 255, 255.192. Should be 3 255s in there. Let's work our way through the rest of these slash numbers. We're going to need them here. A /27, once again, as the first 3 octets are all ones. Go ahead and enter 3 255s. And then notice we have 3 ones. And the reason I started at the bottom here is we know that if there's a 1 in the 128 column, the 1 in the 160, or sorry, 1 in the 128 column, 1 in the 64 column, add those up, that gives us 192. But now there's a new one. This is the 1 column, 2 column, 4 column, 8 column, 16 column, 32 column. What we can do is add 32 onto our 192, because that's the similar parts right here. Add 32 onto here, and that gives us 192 plus 32 gives us 224. /27 is equivalent to 255, 255, 255.224. /28. /28. Once again, first 3 octets are all 1s. 1, 2, 3. The first 3s are equal to 224. We have 1 column, 2 column, 4 column, 8 column. This is the 16. 224 plus 16. That gives us a 240. So our /28 is equal to 255, 255, 255.240. /29. First 3 octets are all 1s. 255, 255, 255. Dot. And we have 4 1s here. The /28 had 4 1s. That was 240. Then we have 1 column, the 1s column, the 2s columns, the 3s columns, the 4s column. And so what we do is take 240. Actually, no. The 1 column, 2s, the 4s, the 8 columns. So we add 8 to the previous value. That gives us 248 right there. /29 is equal to a 255, 255, 255.248. And the last one we're going to do is the /30. /30 here, once again, we have 31s. First 3 columns are all 1s. Gives us 255, 255, 255. And then 1, 2, 3, 4, 5. That's what we had in the previous one. That's equal to 248. The 1s columns, 2s columns. We have a 1 in the 4s column. We go 248 plus 4 gives us 252. /30 is equal to 255, 255, 255.252. Nobody ever really figures out the .31. And once again, the reason for that is there's 0 hosts. There's 2 IP addresses, but you can't use the first one. That's the network address. Can't use the last one. That's the broadcast address. So there are no usable IP addresses in that. Nobody ever figures out that information. Nobody ever uses that. There's no practical place where you would use that, a network with no IP addresses. Now that we have that information, let's get back to filling in our chart. If we scroll back up here, missing a decimal point. Our G00 interface, that's connected to the ASW network. ASW1 network. The ASW1 network is a /28. The /28 decimal subnet mask here, /28 is equal to 255, 255, 255.240. You can go ahead and fill that in. 3 255.240. That gives us our IP address there. Gig 01. Gig 01 on building 1 router connects into the ASW2 network. The ASW2 network, if we scroll down here, look at our ASW2 network information. Here's our network address. This is our first usable address. 10.11.48.65. And it's a /27 subnet mask. Our IP address is .65. And we have a /27 address. We'll go up to the top here, fill in our IP address. 10.11.48.65. Our subnet mask, once again, for ASW2 was a /27. /27 is 255, 255, 255.224. We now can scroll up here, fill in our subnet mask. 3255.224. Building 1 serial interface, they told us to use the first IP address here for this subnet. Let's scroll down and get our network address for this. Once again, this was our WAN link. We have 2 hosts. This is the network address. This is our first IP address. Our first IP address ends in a .121. 10.11.48.121. And then we need our subnet mask. Scroll down here again. It is a /30/30. Right here, a /30 is equal to 255, 255, 255.252. 255.252. There is our IP addressing for building 1. Building 2 is going to go a lot quicker because we built that chart. Let's scroll down and see what our requirements. Assign the first usable IP address to building 2 for the LANs. Assign the last usable IP address for the WAN link. Once again, we are looking at building 2 over here. We have 2 LAN links. This is LAN for the ASW3 switch. This is the LAN for the ASW4 switch. Our two LANs here use the first IP address for these 2 interfaces, and then use the last IP address for the WAN link for this network right here, this interface. Go over here, mouse over this just to verify our IP address. This is gig 00 on building 2 router for our ASW3 network. First IP address on our ASW3 network. Here's our subnet table. This is our network address. This is our first IP address right here. 10.11.48.13. Let's go and fill in our address table. 10.11.48.113. And then we need a subnet mask. Let's scroll back down to our ASW3 information. Our ASW3 LAN information gives us a /29 address. Scroll up to the little table we built. /29 gives us a subnet mask of 255, 255, 255.248. 255 times 3.248. Our gig 01 interface, that once again, that's for this network right here, this interface. That is this ASW4 network. Scroll down to our ASW4. Right here's our information. Our first usable IP address is a .1. Go up here, 10.11.48.1. And our subnet mask. Subnet mask for ASW4 network is a /26. /26 is 255, 255, 255.192 is our subnet mask. 3 255s, .192. And then our serial connection. Our serial connection told us to use the last usable IP address. Once again, there's only 2 IP addresses. We use the first one down here on the building 1 interface. Now we're going to use the last one, or the last remaining IP address up here on this, on the building 2 router. Scroll down here. Here's our WAN link, information about it. In this chart, we have the last usable host address, 10.11.48.122. We'll scroll up here. 10.11.48.122. And then for our WAN link, we had a /30 network. Go up to that little table we built. /30 gives us a 255, 255, 255.252 subnet mask. Let's go on up, fill in our subnet mask. 252. Notice this is the connection here. This is the WAN connection from building 1. This is the WAN connection from building 2. We have 121 here. We have 122. We have the exact same subnet mask ending in .252 to this exact same subnet mask ending in .252. That is the shared network between those devices. Okay, let's scroll down here. That takes care of step 3B. Step 3C, assign the second usable IP address to the switches. Okay, let's go up here. Second usable to the switches. We have ASW1. ASW1 here is on this network. Let's scroll down to our table. ASW1. Our first usable was 10.11.48.97. We have to use the second one, add 1 to that turns it into .98. 10.11.48 and once again we're using the second one here, that's a .98. ASW1 network has a /28 address. /28 address, we're finding our subnet mask. /28 comes out to be a 255.255.255.240. That's our subnet mask. We can go up here, fill in that information. 255.255.255.240. And then the last piece we need to figure out is the default gateway for our ASW1 switch. ASW1 switch is on this local area network. This is the default gateway. This interface right here, the connection on and off of our network, this is the default gateway. We need this IP address as our default gateway. If we look at it once again, this is gig 00 on building 1, gig 00. This is the IP address. And so that is our default gateway for the ASW1 switch. 10.11.48.97. Okay, let's go on to switch 2. Switch 2 is our ASW2 switch. ASW2 LAN. Here's our information. Our first IP address, first usable, is .65. We want the second one, so we add 1 to that. That gives us a .66. We'll scroll up here. Fill that in, 10.11.48.66. Need to get our subnet mask. Scroll back down. Once again, we are talking ASW2. ASW2 is a /27. Scroll up to our little chart we built. /27 is 255.255.255.224. Go ahead and fill that in. 224. And now we need the default gateway. We are looking at this network over here. We're going with host B, ASW2, and this interface right here on the building 1 router. This is our exit on and off the network. If we mouse over, we can see that we are looking at gig 00 on building 1. Right here is building 1, gig 00. This is our IP address on gig 01, which is our default gateway right here. 10.11.48.65. ASW3 switch, that's this network over here. We have to get the second usable IP address to assign to VLAN 1. ASW3, here's our information. Here's the first usable address, add 1 to that, that gives us 114. Go up here, add that in here, 10.11.48.114. ASW3 network is a /29. /29 on our little chart here gives us 255.255.255.248. That is our subnet mask there for our ASW3 switch, .248. .248. There we go. Now we need the default gateway. Once again, we are looking at this network here, one with host C, ASW3 switch, and this interface right here. This is the interface. This is our exit on and off of our network. This is our default gateway for any host on our local area network. I'm going to go ahead and mouse over this. It says that we're looking at gig 00 on building 2. Here's building 2. Gig 00 is right here. This is the IP address assigned to gig 00, which is also the default gateway for the ASW3 switch. 10.11.48.113. Last switch we have to do here is the ASW4 switch. ASW4 switch is on the ASW4 LAN. Here's our information. Once again, this was the biggest one we did, had the biggest requirements. That's why we did that first in this chart. Here is the first IP address that's assigned to the router. We want the second one, add 1 to that. That gives us a .2. Scroll on up. We can fill in our chart, 10.11.48.2. We need to get our subnet mask. Scroll back down. Our AS4 LAN has a /26 address. You scroll up to the table we built. /26 gives us 255.255.255.192. That is our subnet mask for this ASW4 LAN there. And once again, that was 255.255.255.192. And we need to get the default gateway for this local area network that has host D and the ASW4 switch, which is this interface right here on the building 2. What I'm going to do is click in there, mouse over the green triangle. Green triangle will say that it is, well, this one was gig 00. This one should be gig 01 at that point in time. Over here is building 2, gig 01. This is the IP address that's assigned to that, which is our default gateway for our ASW4 switch. 10.11.48.1. There's all the information for our 4 switches: IP addresses, subnet mask, and default gateway. All we have to do is our PCs, host A, B, C, and D, and we are done filling out this chart. Let's scroll down, find out what address they're telling us to use. Step 3D, assign the last usable IP address to the host. Last usable will get the PCs on this network. Okay, starting off with host A. Host A is on the ASW1 network. ASW1 network is right here. Looking at our information, last usable was 110. Is 110 right there. We can go ahead and scroll up. Our IP address 10.11.48.110. Last usable IP address in that first network. Subnet mask here. Once again for the ASW1 network. I'm going to scroll down here. For the ASW1 network is a /28 address. We scroll up here to the /28. We can see that our decimal subnet mask is 255.255.255.240. There we go. 255.255.255.240. And we need our default gateway. We are looking at host A. Host A is on this network. And once again, this network goes up to this interface right here, the building 1 interface. If I mouse over this little triangle says this is gig 00. It's kind of hidden a little bit, but it's gig 00. We can scroll up here a little, go to building 1 router, gig 00 interface. This is the IP address of our gig 00 interface, which is the default gateway for our host A. 10.11.48.97. There we go. And once again, notice host A and ASW1 switch, they have the same default gateway because they are on the same network. Right here's the ASW1 default gateway. Here's the host A default gateway. Same default gateway because they are on the same network. They have the same exit on and off. Host B. Host B is over here on our ASW2 network. Get the last IP address. We can scroll down to this table. The ASW2 network. Here's our information. Here's our last IP address. Ends in .94. Scrolling up to our table, we can fill that in. 10.11.48.94. Host B is on the ASW2 network. Scroll down, ASW2 network here is a /27 network. Scroll up to our table we built, /27 is a 255.255.224 subnet mask. In our default gateway, once again, this is our network right here. This is our exit on and off of our network. If I mouse over this triangle, it tells me I'm looking at building 1's gig 01 interface. Scroll up a little, building 1 gig 01 interface is this IP address, which is the default gateway for this entire local area network, the ASW2 local network. And so that IP address was 10.11.48.65. Host C. Host C is on the ASW3 network. Let's go get the last IP address. The ASW3 network. Here's ASW3 network address. First usable, last usable is a .118. Scroll up, fill in our chart. 10.11.48.118. We need to get the subnet mask. Let's scroll back down. For our ASW3 network, that is a /29 address. /29, scroll up to this little table here. /29 is a 255.255.248 subnet mask. We can fill that field in now. .248. Host C, whoops. Host C is on this network once again with the ASW3 switch. And this interface, this here is our default gateway. Our default gateway is our exit on and off the network. If I mouse over this, it'll tell me I'm looking at building 2 gig 00 interface. Here's building 2 gig 00 interface. This is our IP address of that interface, which is anybody on that local area network. That is their default gateway. 10.11.48.113. And our last and final IP address we have to figure out for host D. Host D is on the ASW4 network. Let's scroll down. ASW4 network, here's our information. Our network address, first usable, last usable is a .62. We can go up here, put in our IP address. 10.11.48.62. We need to get the subnet mask. ASW4 is a /26. /26, if we scroll up to our chart, here is a 255.255.192 subnet mask. We can fill in that field. 255.192. And then last thing we need is this default gateway. For this network right here, it's this interface. If we mouse over it, it says gig 01. It's a little layered. It's behind something, but it is gig 01. Let's go ahead and look at building 2, gig 01. Gig 01 IP address is this, which is the default gateway for this network over here. I can go ahead and put that in there, 10.11.48.1. That fills out our addressing table. It is all filled out now. Once again, we did the VLSM, we did the variable length subnet masking to get all of these addresses. The lab gave us some requirements, just right here, very minimal requirements on what to do. And we were able to build that entire table. On to part 3, assign the IP addresses. We figured out what they were, we built the table. Now let's go ahead and assign that. Step 1, assign IP addressing on the building 1 router interfaces. Let's go into building 1, router right there. I clicked on it. Notice the only thing we have access to is the CLI. I did make this window a little bit bigger, so we can see that. I'm going to hit enter a couple times, give me a clean working order. Configure the IP addressing on building 1. If we scroll up to our chart here, building 1, we have 3 interfaces, 3 IP addresses. First thing I'm going to do is I'm going to go from user exec mode to privilege exec mode, type enable, hit enter, and then I want to see what's configured. And so for me to do that, the command I'm going to do is see what's in RAM. The command here is show running config, show space run, and then I hit tab, finishes out. I go ahead, hit enter, I hit spacebar, take me down, and if we look here, gig 00 has nothing configured. There's no IP address, it's shut down. Gig 01, it's no IP address, it's shut down. Serial 00 has an IP address, and it doesn't say shutdown, so that means it's turned on. What I need to do is go and configure the gig 00 interface and the gig 01 interface. I hit spacebar a couple more times, takes me down to the end. We are in privilege exec mode. We need to go into global configuration mode. Again, in global configuration mode, we type config T. Now we're there. Now we need to go into each one of those interfaces. So we go into interface G0/0. The IP address for G00 is right here, and the subnet mask. IP space address space, and then we can go ahead and type our address in. Once again, that comes right from this chart right here. 10.11.48.97. And because we're setting the IP address, we have to put the subnet mask in there. 255. Oh, I forgot my decimals. Starting over with my subnet mask. 255.255.255.240. Go ahead and enter. Remember, the port was off. We'll go ahead and turn it on. You do the no shutdown command. No space shutdown. Turns it on. Hit enter. Look at that. Our interface went up, meaning we turned it on. Our line protocol, we've configured IP version 4 on that. And we are up to 23% completion. Hit enter a couple more times, gives us clean working area. Now we need to configure the gig 01 interface. We don't have to exit out. All we have to do is tell it what interface we're going into, because we're configuring interfaces. So int space G0/1. We assume it worked because it didn't tell us we did something wrong. In Cisco's world, if you no news is good news. If you do it correctly, it's not going to typically let you know. If you do it wrong, it will definitely let you know. And so we have now changed into our interface for G01. We have to set the IP address. We can get that from our addressing table right here. IP space address space, and then here's our IP address. 10.11.48.65, and since we're setting the IP address, we need to specify what the subnet mask is. 255.255.255.224. Need to turn the interface on, space no shutdown. Interface goes up, line protocol goes up, and we are now at 46% completion. We're making good progress. Once again, notice we have IP addresses, we have a subnet mask. Up here it ended in .240 for our gig 00 interface. Down here it ends in a .224 for our gig 01 interface. Two different networks had different requirements for number of hosts. That's what gave us our two separate subnet masks. Okay, let's scroll down here. We did step 1, configure the IP addresses on building 1. Configure IP addressing, including the default gateway on the AS3 switch. I'm going to go ahead and close that out. I'm going to click on the AS3 switch, slide it over, make the window a little bit bigger, just so everything wraps nicely. Hit enter several times. Once again, we are setting the IP address and the default gateway. Let's scroll back up here. We are on the ASW3 switch. Here's the information we need. We have our IP address, which we use the last IP address. No, we use the second one. That's right. The first one goes to a default gateway. Second one went to the switch. Here's our subnet mask. Here's our default gateway. All the information we need. We are at the greater than prompt. We are in user exec mode. Type in enable, brings us into privilege exec mode. Once we're in privilege exec mode, let's go into global configuration mode, config T. And we want to configure the interface for VLAN 1. So interface space VLAN 1. Notice we are now configuring an interface. Now we can apply our IP address. So IP space address space. And once again, here's our information. Ends in a .114. Here's our subnet mask. We can enter that in 10.11.48.114. That sets our IP address. Because we're setting an IP address, we need to specify our subnet mask. 255.255.255.248. We get that from our chart right here. Go ahead and hit enter. Good habit, always do a no shutdown. Anytime you do anything with an interface. I spelled no shutdown wrong. There we go. Notice VLAN 1 went up. Our line protocol went up at that point in time. Last thing we have to do on ASW3 is set the default gateway. The default gateway is not attached to an interface, so we need to be in global configuration mode. We go ahead and we type exit here to get us out of the configuration of the interface in the global configuration mode. And now we can go ahead and set our default gateway. Because it's an IP, part of the IP protocol, it's IP, then default. I type in first couple characters, hit tab for completion, and then we set in our default gateway, 10.11.48.113, 10.11.48.113. That sets our default gateway. Because we are pointing the default gateway at an existing IP, we're not setting it up. We don't have to specify the subnet mask at that point. Go ahead, hit enter. Once we are done there, exit out. Good to go. Scroll down. And then verify. Oh, and then we have to configure host D, including the default gateway. You have to put the IP address on host D. I'm going to go ahead and minimize this. Click on host D. Once we're in host D, I'm going to click on the IP configuration tab. Scroll back up to our IP addressing table. Host D right here is our information, our IP address, our subnet mask, and our default gateway. I'm going to go ahead and put in our IP address, 10.11.48.62. Subnet mask, when we go down there, it auto-populates it based on what class the address is. Here it's a 255, but that's not our subnet mask. So we have to go in and completely modify that. 255.255.255.192. I got that from our addressing table here on the right. And the last thing we need to do is specify our default gateway. Our default gateway is right here in our addressing table. I'm going to take that information and put that in there, 10.11.48.1. Notice I'm still at 93% because I'm still in that field. Once I click to a different field, I commit that number to packet tracer. I am now at a completion of 100%. We have completed the lab. Last step is verify our connection. You can only ping from building 1, host, or building 1, ASW3, and host D. What I'm going to do is I'm going to go to host D. I am going to open up the command prompt. I'm going to scroll up here. And then I'm just going to start pinging all these IP addresses. I'm going to start pinging with the building 1 router 10.11.48.97. That works. The G0 is our interface. Now I'm going to ping the G01 interface. 10.11.48.65. That works good. Next one I'm going to ping is the serial 000 interface. Ping 10.11.48.121. There we go. Works great. Now I'm going to ping building 2 router. These 3 IP addresses. Ping 10.11.48.113. This is right where we're at. Go ahead and hit enter. That one works. Going to ping the G01 interface. 10.11.48.1. Oh, I typed it wrong. We have to wait for it to time out. Up arrow is our friend. I have to change that 1 to a 10. Hit enter. Now it works. Now that I have the right IP address in there. That was the gig 01 interface. Now we're going to do the serial 00 interface. Ping 10. Wow. Ping 10.11.48.122. I'm missing that 0 and the 10 all the time. Correct it. Working just fine. So building 2 router works. I'm going to go ahead and ping all 4 switches. Start with ASW1. Ping 10.11.48.98. Timing out here, but we have to go through the ARP protocol. And we may get 1 or 2 failures here, but then it should kick in. There we go. If I repeat that command, up arrow is your friend. I'm just going to hit up arrow once, hit enter. All 4 pings are going to work great. I'm going to ping ASW2. It's going to have to go through the ARP process again. Probably fail the first 1 or 2 times. There's the first failure. And we have a second failure. Third, fourth one works. Up arrow, repeat the ping command. All 4 work. We're going to ping ASW3 switch. Ping 10.11.48.114. If I had to guess, we're going to have 2 failures and 2 successes. We're doing the address resolution protocol. We have our 1 failure. We are looking for a second one, and then there it is. Up arrow, repeat the command. All 4 work successfully. Beautiful, and we're going to ping the last switch, ASW4. PING space 10.11.48.2. And once again, I'm guessing we're going to have 2 failures. First failure. Oh, only had 1 failure this time. Up arrow again, repeat it. All 4 are going to work. Last thing we have to do is ping the remaining 3 PCs. And so ping 10.11.48.110. Hopefully it's going through its ARP process. Oh, it looks like it. I'm going to repeat the ping just to make sure all 4 worked. There it goes. Host A worked great. We're going to ping host B. There it is. Probably have to do an ARP lookup again. First one will fail. Maybe the second one might. Oh, only 1 failed again. Repeat that to make sure all 4 works. And the last address we have to do is ping PCC. Ping 10.11.48.118. 10.11. Oh, I forgot the 0 on 10. Let's correct that. See what happens. Hopefully we have 1 failure for the ARP process, and then 3 will work. There we go. I'm going to repeat the ping 1 more time. All 4 worked. Our device was able to ping all of our devices. We have complete connectivity. We were given the requirements. We did Vlsm. variable length subnet masking. We came up with the addressing scheme. We applied those, and now we verified connectivity. That was Packet Tracer Lab 11.9.3 Vlsm Design and Implementation Practice. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.